Guys, here we go. In this video, we are going to be examining some special right triangles. So we're going to be looking at two different types of triangles today, and we identify them based on their angle measures. So we're going to talk about a 45, 45, 90 triangle. All right, and that, of course, is just an isosceles right triangle because it has two congruent angles, meaning it has two congruent sides. And the other one we're going to look at is a 30, 60, 90 triangle. Sorry about that. I guess I'm having a little bit of trouble with my pen right now. All right, so again, these are the angle measures. So let's start off by looking at a 45, 45, 90 triangle. All right, I'm just going to draw one. All right, it looks like it's kind of to scale here. And these are congruent. We are going to call one of these side lengths x. Okay, if this one is x, we also know that this leg is x. So let's solve for the hypotenuse here. I'll call the hypotenuse h. All right, so I've got x squared plus x squared equals h squared. That's 2x squared equals h squared. Now to solve for h, I'm just going to take the square root of each side. So h equals the square root of 2x squared. We can actually simplify that. We have 2 times x squared. Well, I can take the square root of x squared, which is just x. That comes outside. So x times the square root of 2 is the length of that side. And this is always going to be the ratio. All right, this is always going to be the ratio of the side lengths of a 45, 45, 90 triangle. Okay, that will always be true. So what I like to do is take that, and when I'm starting off a problem with a 45, 45, 90 triangle, I write out, here is my ratio, x root 2. Boom. And then that will help me. We will run through a couple of examples later on. All right, next for a 30, 60, 90 triangle. This one's a little bit tougher to prove. We are going to do it though. All right, let's do it. So I'm going to start actually by drawing an equilateral triangle, which is kind of interesting. And I'm going to say that each side has a length of 2x, 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 2x. Then I am going to draw an altitude right here. I'm going to drop an altitude. So that's a 90-degree angle. Well, what does the altitude do to this triangle? It's actually it's also the perpendicular bisector of the other side as well as the angle bisector. So this angle was just bisected. I know this angle is 60 degrees, this angle is 30 degrees, this side is 2x, and now this side I'll just call x. Okay, this side I'm just going to call x. Let's erase the other part of the triangle now. Okay, let's just ignore that. I now can see I clearly have a 30, 60, 90 triangle. Again, the reason I know that this side was x was because that altitude bisected that side. All right, so it was 2x, bang, now it's just x. All right, beautiful. Let's solve for what that other leg is. I'll call that leg L, and we want to solve for it. So we have x squared plus L squared plus, equals 2x squared. And of course, that 2x is in parentheses. We're squaring that whole side. Okay, when I square that, I get x squared plus L squared equals 2 squared is 4. X squared is x squared. I'll subtract x squared, so I now have 3x squared. And then I take the square root in order to solve for L. So square root of 3 times x squared, well, again, I know the square root of x squared is just x. So I get L equals x times the square root of 3. All right, so this side here is x square root of 3. All right, again, same thing. I'm going to write this underneath 30, 60, 90. That is always going to be the ratio of my side lengths. And I'm going to pair it up so it's the opposite ones. So the x is opposite the 30, okay? The side that's opposite the angle. X root 3 is opposite the 60, and 2x is opposite the 90. So this will help you. X root 3, 2x. All right, in summary, of course, we got our 45, 45, 90. We've got x root 2. And our 30, 60, 90, we've got x x root 3, 2x. All right, this should help you. You should have this. Let's use that for this problem. All right, our first example, we've got this 45, 45, 90 triangle. How do I know that that's true? They tell us that these two angles are congruent. 45, 45. So could I set this up and say, oh, x squared plus x squared equals 8 squared? Yeah, you definitely could. That's still an option. All right, I'm not going to tell you that you're not allowed to do that. You definitely can. However, now we have an easier way. Okay, 45, 45, 90, we know has a ratio of x root 2. Well, this 8 is in the position, it's opposite this 90-degree angle, meaning that it represents this x root 2. So I'll just set it up as x times root 2 equals 8. So x equals 8 divided by square root of 2. We've learned how to solve these. We'll multiply by square root of 2 over square root of 2. We'll get 8 root 2 over 2, which then gives us x equals 4 times the square root of 2. All right, so this side here is 4 square root of 2, and this side here is 4 square root of 2. All right, beautiful. Moving along to our next one. We got a 30, 60, 90. Let's just write out our ratio here. We go 30, 60, 90. That's x root 3, 2x. All right, and what I'm actually going to do to make this a little bit tougher on ourselves, let's switch the x and the y. All right, because I think that this can be important. Oops, I just put the y right back where it was. Okay, this is important. It sometimes trips people up. When we put x up here, it doesn't necessarily need to be x right here. Okay, you can definitely get confused if you have an x in the actual problem that doesn't represent the side that's has length x. So if you want to change it, okay, and I would highly suggest this, okay, if you want to change it, maybe you make it a variable that's not a part of the problem. I'll call it a square root of 3, 2a. Okay, you could have also changed it to y square root of 3, and 2y, just because y does represent that side length. All right, so it's really up to you, but I just want you guys to be careful with that. Be careful. So now I got that a times the square root of 3 is equal to 9. Okay, because again, the 9 is opposite my 60-degree angle. Opposite my 60-degree angle is that side a root 3. So solving for a then, I just get a equals 9 divided by square root of 3. I'll multiply by square root of 3 over square root of 3. That gives me 9 root 3 over 3, which is then 3 root 3. Okay, it is important to note that this is the side opposite the 30-degree angle. So it's this side right here, y. So y is equal to 3 square root of 3. So that's why I'm saying if you don't want to put a here, if you would rather just jump straight to the gun and say, well, I'm just going to call it y. All right, and then for x, we know x is just going to be twice that. So I'm going to say that x is equal to 2 times 3 root 3, giving us x equals 6 square root of 3. All right, best of luck, guys. I hope that this helps you on your work.